Hello, everyone. This is Professor Lobel. I just wanted to take a moment and give you some information about the Lab 2 assignment. First of all, the Lab 2 assignment is something new for me. I've been exploring with our pandemic going on some other ways to get information and assignments to you that are unique and interesting. So that said, this assignment is really the first one. We can't really count the tube one too much because that was Ed puzzle that didn't really work out for us. So you're going to see that the Lab 3 assignment is similar to this one, except it's not fill in the blank. It's all multiple choice, which will help. I may have bit off a little bit more than I could chew on this one, having to go into each one. And someone, by the way, please let me know if you received my comments because I commented on a lot of the incorrect answers. That said, there weren't that many questions on this as well. So if you got one wrong, you got a 67, unfortunately. But the fortunate thing is, I've yet to decide really how much these homework assignments really are going to count towards your grade. So, especially at the beginning here, I wouldn't worry too much. It's more to me that you are participating, right, than to try to use these grades in a meaningful manner towards your overall grade. So that said, let's go over a couple of these. Which side of the step wedge will appear the least dark? In other words, the brightest. So which side of the step wedge will appear the least dark? That should be the thick side. And the rationale here, which I'll describe more below, is that if we're not talking about average atomic number, and we're not because the step wedge is made completely out of aluminum, it's just one substance, then the only way to distinguish different types of grayscales, in other words, contrast, is based on thickness alone. Whereas if we're looking at the body, it's not just thickness, it's atomic number, average atomic number, as well as something known as tissue density that'll be explored in another class. So in this case, the thick side absorbed more of the X-ray photons. We only took one exposure, and I think people got a little bit confused when they were talking about intensity. The intensity was set on the console. We used a particular kV, a particular MA, particular time, leading to a particular mass or milliampere seconds. So the thick side absorbed more of that intensity. Okay. So when the image receptor directly underneath that thick area did not get as much radiation as the thinner side, which would have transmitted more photons through it, the system is designed to reconstruct that and give an area where it doesn't receive as much radiation a lighter or brighter shade of gray. And that's why we saw the thick side be bright and it would get darker and darker and darker as the steps got thinner and thinner. So which area of the step wedge appears the darkest and why? I tried to explain that just now, but essentially the thin step appears darkest because it allowed or allows more X-ray photons to be transmitted through it compared to the thick side, which absorbs more. So again, the intensity was already set at the beginning. So we're talking about changes in radiation intensity as felt by the image receptor based on the thickness of the object on top of it. So, in other words, if we started with 10,000 photons, and it's many, many more, of course, than that, um, then all 10,000 of those photons are flying towards the step wedge. Some more than others get absorbed in the thick side, and on the thinner side, more go through. And it's that number in those areas, right? In other words, different parts of the image receptor, different parts of the phosphor receiving more or less photons than adjacent areas is going to in the reconstruction determine how gray or dark or bright a particular area is on your ultimate image. So, what do you conclude about the relationship between the intensity of X ray exposure and the amount of blackening on the processed image? So, by the way, I tried to flesh out some of my answers here for, good learning purposes. But I was very, very happy when I saw people, with just one or two sentences, just give me the answer. A lot of people were talking about increasing KV and changing the intensity. I want you to again be aware that the only intensity changes that occurred were those that were felt by the image receptor, a CR plate, or a flat panel detector. The original intensity is what it was, created initially by your set of KV, MA, and time. So, what can we conclude about the relationship between the intensity of X ray exposure and the amount of blackening or darkening on the processed image? So, this experiment utilized only one exposure, so the intensity yielded was based on the KV and the mass set, as I mentioned. That said, the intensity as felt by the image receptor, so either a flat panel detector like room one or a CR cassette, so the intensity as felt by the image receptor in certain areas varies depending on the thickness of the wedge over that area of the image receptor. And the system, as I've mentioned, is designed such that the phosphor areas that receive more radiation, a higher radiation intensity compared to the other steps, not your initial exposure and how much was created before these photons even interacted with the wedge. Okay, so I'll read that sentence again, though. The system is designed such that the phosphor areas that receive more radiation will be darker or less bright, but darker sounds easier to say, right? And areas receiving lower amounts of radiation will be lighter, sometimes referred to this as brighter. So, everyone, I hope that explains things. If you do need to see specifically which ones you got wrong, um, and it's probably only one, if you got less than 100, essentially. It's almost as if this was pass fail. That was not really the intention. But if you want to see specifically which one you got wrong, uh, please contact Radiologic Tech at citytech.cuny.edu, which is our secretary monitors that, and make an appointment to see me. We'll go online. We'll do a quick Zoom, most likely, is the easiest way to do this. And I will go into my Google Forms and pull up your actual uh, assignment. So, everyone, I hope that was somewhat useful. And I'll see you all on Monday. Have a good rest of the weekend.